one of the key responsibilities of your role, which is failure analysis. So we haven't discussed this in a lot of detail in a little bit on our podcast, but can you just walk us through the importance of failure analysis and maybe some of the problem-solving methods or analytical methods that you use when trying to identify the root cause of a failure?
So failure analysis is really important. All the fields, I would say that one, because that will give you the chance of, or I would say the opportunity for improvement, either in the process side or either in the product side. So so failure analysis is really important. And then we can use various tools depending on the what type of the product failure is looks like. Like
Hello, hello. Welcome back to the It's a Material World podcast. I'm your host, Heath. I'm with my co-host, David. How's it going?
Pretty good. I just returned from Europe where I went for some work travel. So pretty jet lagged.
How
Um,
was that,
I
David? Like, how
oh,
much of it
it was
was like actually like in the factory or, versus like getting some time to explore Germany, if anything?
yeah. So I did work, but luckily the weekend was mine. So I went around and saw a bunch of sites. So
Nice.
it was very fun. My second or third time being to Europe. So it was lots of fun, but yeah, it's like a 9-hour time difference from California.
Really?
So I found myself falling asleep at like 8 or 9 p.m. and waking up at like 6 or 7. So I'm still getting used to the time difference, but
Yeah, for sure.
it was a good time. But I think it was a good time. How about you? How are you feeling?
I'm good. I'm good. I've been a little bit sick under the weather this week. You can maybe hear it in my voice. So this is kind of, recording this podcast is like a Michael Jordan flu game, if you will. But
As
uh
a bold take to claim for yourself there, but okay.
I mean, it's the same thing, I would say. I was thinking, just kind of looking at our backgrounds, we've moved around quite a bit. Like, we've had a bunch of different podcast backgrounds, whether it's different, if, in different settings with different internships or back in Atlanta, or, me in Minneapolis, St. Paul, and now Chicago. So it's just kind of cool to see just over time, over the past few years, just like, how our lives have changed, how we've moved around to a lot of different places. But yeah, I mean, overall, I've been good. Went to a wedding last weekend as well. So it's just another reminder of us, getting older, but also seeing like our friends having like major life accomplishments. It's been a good time.
Well, yeah, so we can jump into today's episode where we talk to Nick Tandel, who's the head of quality and process at ASWPengg, where he talks mostly about metallurgy and failure analysis of metallurgy. And he was very informative as he talks about the entire process as well. He does, what does metallurgy do in general, and kind of just a broad overview of the field as he's had lots of experience. So, with that being said, what was your favorite part of the episode?
Yeah, I think it was cool hearing about specifically failure analysis and what you're looking at, like the methodologies that you implement, but also the material science principles that you learn in class and how you implement the combination of the two to kind of get to the root cause, specifically in process, if there's any failures or anything that you have to kind of continue to dive into and adjust so that you can get back to manufacturing efficiently and at a high level of quality. So he touched on a lot of different principles, whether it's like the lean problem solving, lean manufacturing, but also the failure analysis methods or the tools that you can use, whether it's optical microscopy to look at the microstructure or in, a higher level scanning electron microscopy as well. So it just was kind of like, it just reminded me of my past experiences, are the class like the metallurgy classes that we took talking about martensite and austenizing temperature, and then also my internship where we were learning about lean and Six Sigma methodologies, and then also materials characterization as well. So it was just really cool to see how all of those can come into play and how he leverages those as well as just continuous innovation on the manufacturing side to like 2x his company's revenue in 1 year. That's just a crazy feat. So it was just cool to see how the results can come from what we've learned in our academic and industrial settings. What about you?
Yeah, I thought it was really interesting that usually when we talk to guests, we're talking about the end product. So the startup who's making this one product and trying to revolutionize the field. But from his point of view, it's more of the manufacturer, like the supplier. And so they mostly focus on spring wire, which is then sent to a bunch of different manufacturers for their end product. So it's interesting to hear about the process of creating from raw material to the actual material that will be used to be the final manufactured equipment, and how that goes into how you talk about process, how you talk about scaling, and more of a generalized approach, but still making it at scale. And so where, for example, you or I would be focused on maybe one or two products, he's focused on like 10 or like 20, where he has to check the quality of each of these different products, check the process of each of these different products to see how that affects like the final output. And so I thought that was an interesting take about hearing his thought process on how the entire process works to be able to produce and provide for a bunch of different applications.
For sure, for sure. And at the end of the episode, he also just shares advice for material science students on kind of how to successfully implement a lot of those failure analysis methodologies and maybe what classes to take, internships, etc., what methodologies to learn to set themselves up for success in a process or manufacturing role. Doesn't even have to be metallurgy focused. I thought his advice was very comprehensive for all different fields. So, a lot we discussed in this episode. Before we get into it, I wanted to ask if you guys could leave a rating and review on your favorite podcast platform. That would mean the world to us. It helps promote our podcast to more people who are interested in the field of material science and get more people involved in our community. So now let's get right into the episode.
All right, hello everyone. In today's episode, I'm very excited to welcome Nick Tandel, a process metallurgist and head of quality at ASWPengg LLC, a company that focuses on the manufacturing of various types of spring wire. Nick earned his master's in MSE from New Jersey Institute of Technology in 2017 after earning his bachelor's in metallurgical engineering at the Government Engineering College in India. Nix has held several metallurgical engineering roles ranging in a scope from lean manufacturing at Alpha Gamma Abrasive Products to customer and supplier interactions at Rocknell Fastener to his current role at ASW Peng in failure analysis and root cause analysis. Nix has 7 years of experience in metallurgy, and I'm excited for this conversation. Thanks so much for joining us today.
Thank you, David, for the brief introduction. I really appreciate that, and thank you for having me here.
Yeah. So, Nix, let's start with your story and why you got into metallurgy. To us, to me, it feels like metallurgy was kind of the precursor to this new, I guess, major with material science and engineering, but it still plays a very key part in the field of material science. So, can you just talk us through what got you interested in metallurgy and why you're so passionate about it today?
Sure, definitely. So, I think so. This my journey for metallurgy has started at really young age while I was in high school. So where it's mainly we have a family manufacturing business. So my father is also metallurgist, and I was seeing him in the family business, how he's doing, how he's developing the stuff. And since then, I've been more curious about the how the whole metallurgy field works. And then after the high school, I start pursuing my undergrad in the metallurgical engineering field. So after that, when I start doing more undergraduation work, I realized start doing the internship in my field. I start learning the more practical knowledge alongside with my theoretical background knowledge. And after that, I start doing involving more and more because in the undergraduate, all the courses, new courses comes every semester. So I was kind of reading the theoretical knowledge and applying on my like practical knowledge with my together with my father, which was it was greatly mentored by my father. And since then I'm like more curious in metallurgical field, and then I did more failure analysis and all different stuffs on that one. So that's kind of like my short journey over there in the metallurgical field.
Interesting. Well, also, it seems from previous conversations that you've worked both remote and in person in the field of metallurgy. I kind of want to just dive into first, like, what is a typical like day of a metallurgist, and then like how you can actually do some of this physical work remote, but what is the benefits of being in person in the factory as well?
Yeah, sure, definitely. Let's start with very small basic definition of metallurgy. So basically, metallurgy is a very specific field of materials science, which focuses on particularly on the metals like aluminum, steel, iron, or the special metals like titanium. So as my day-to-day activity involves like analyzing the process chart throughout the day or the yesterday, how it been, the all processes has been ran through because those processes directly impacts the product quality or the finished product. So I will be analyzing those process analysis on that one. Then apart from that one, we'll be involved in the microstructure analysis of the particular product, which is like very key. I would say the very key quality factor, which determines the quality of the product. In the microstructure level, you can see what type of the microstructure it is and is it the good for that particular product or not. And as well as the mechanical testing data from the previous or the current day in order to see the product quality has been proper or as per the customer standards or not. And as a metallurgist, I also do the failure analysis. If we are having the internal failure analysis or the external failure analysis, then I will be going along with the teams. What are this particular failure has been happened on the process side, and then how did that happen? What was that particular metal, or what was that particular product? Was that, and then we'll be going from that using that particular root cause analysis and various tools using that one. And yeah, so this is like some brief introduction on as a metallurgist, my day-to-day activities, but there are a few more other stuffs will be also going on, working with the executive teams to making sure like working on the new product development or like doing the commissioning of the new machine installation to make sure our new product development will work through that and various other stuff.
I'm curious to the effect of working remote versus in person. It sounds like a lot of what your job does is analysis of either microstructure or process. And so it sounds like a lot of it can be figured out at home. But I also want to hear your thoughts about going to the factory yourself and seeing the process done in person.
I think so. It all depends, like materials on that one. Like I would say, like currently in my role, where it's most of the time I need to be in person in the operation side because that involves failure analysis and root cause analysis on the material side. Like even the day-to-day activity, I have to analyze the microstructure. You can have the photographs and all available from the your work location, but the as a metallurgist, I personally feel that one as soon as I see the microstructure using the optical like microscope, then it makes more sense to take is this the perfect microstructure or not. So it goes on that what is the day-to-day activity looks like. If it's you are involved more on the process side doing the investigation, checking in the microstructure side and doing the various testing. If you are involved in the R&D side like the doing the new product development, it's very important that you are on site, how the process is working, how you are carrying out the new product development with the team, because that involves a lot of cross-functional team work and also the communication with the team. And then we can make sure that the product what we have developed it's as per the specification. So and there are some roles where you can do the hybrid, but it's not like 100% you can do remote, but most of the time it's involves the in-person testing and all the stuff.
Yeah, that makes sense. I think especially when you're trying to do root cause analysis or anything like that on the process side, then, they call it going to Gemba, go to where the work
Yeah,
is done, right? Walk the line, see what's happening. So,
exactly.
there's a lot of power in that, obviously. But I want to focus on the products that you're mentioning, right? I know your company specifically works on various types of spring wires, so that can be a niche field. So I was just wondering, what are the differences between your spring wire product portfolio? Does, you know, one product or manufacturing of one product require a completely different knowledge base of metallurgy, or are you applying a lot of the same principles? Kind of how does your role differ for the manufacturing of one spring wire versus another, if there is any difference?
Yeah, sure. So we do manufacture the various spring wire products that goes into the various industries, such as like automobile or the agriculture, or recently like fiber optics markets as well. So different. It all depends on the what's our end customer requirements are. Like all the wire size could be the similar, but the product application will be the various differently. And so, like one of the we are producing currently on the very fine wire size, it could be range from the 0.1 inch to the 0.87 inch, which is considered in the wire industry fine size. And those are products used into the automobile engine transmission rings. Then other products are used into the like developing the 5G technology or fiber optics market. So again, that goes to the different individual products that I has been manufacturing. So all products that we are manufacturing will be depend on the what processes we are using that one, and then based on that processes, all the characteristics will be the different for that particular products. Yeah, I mean, again, it's very tricky to define. It is similar or different, but like I would definitely would love to say that one that is in the spring manufacturing, there is a uh, spring products which particularly goes into the automobile engine transmission. Then there is a how we call it the hard drawn, which doesn't go to the oil tempering process, which is like one of the heat treatment process, and that will be the that application will be the different. Like some products will go into the like in the very simple example will be the car seat. You press the button, it goes back and forth. So there is a spring involved. It's in that like some of the our wire will be it goes to that our customer and they make that particular spring. So that will be used into the car seat, or they will make the very small spring that will go into the transmission ring. Yeah. So again, this depends on the how the end customer requirement will be, what our client will requirement will be.
So you kind of mentioned there that for automotive, even for like a transmission spring ring or other parts, the way you treat it, like a oil treatment, can differ, and that's like the main process differences. Could you maybe go a little bit deeper and tell us like, are all spring rings like made and then the treatments are different? Or it seems like you do such a wide range of products. How is it like feasible to mass scale produce all these at the same plant in a way that it works, that you can produce all these niche applications while still being like efficient and not having like a million different products that you have to make from scratch?
Yeah, so what I would love to do that I will definitely go over through the spring manufacturing process. So
Yep.
that will kind of give you the idea how the whole spring wire that manufactured, because basically what we are doing is manufacturing the spring wire, and then we ship it to our customer. They will make the spring from that particular wire. So let's go over through that spring wire manufacturing process. So what happens is we will take the wire rod, which can be the various range from the various rod vendor. Those steel rod vendor will be across the states or across the globe. Once we will get this that particular wire rod, we will do the depending on, again, this goes to the end product what you are planning to manufacture. So we do plan in advance that once the material arrives, what's the next finished product that for that particular product. After that, we will do the depending on the product requirement, there is a various equipment process will be involved initially, or it could be the directly cold forming. The basically cold forming process will be like you take particular size of the wire. So like I have this, you have this size of wire, right? So you draw it down using the cold forming. So this will be very size like this, very fine size, or the intermediate size we call it. And then after that, if you end product is ready for oil tempering process, then you will ship it to the oil tempering process, which is like the heat treatment process. So just to give you the brief overview on that, what is heat treatment? If someone asks me, then it's very, I would describe in the very simple way that you can change that without changing this particular product appearance. You will change its internal mechanical properties. That's where the microstructure gets involved. That is it the properly heat treated part or not. So then we will have that cold forming process. After that, we could be doing the one of the heat treatment process. We call it the patenting. The patenting process is also a treatment process, but that makes the wire more softer. If you wanna do the more further cold forming or wire drawing process in that particular wire rod, because there is a very all the like from the wire rod to the like for example, you are on the 0350 inch wire rod, and if you want to go directly to the 0150, there is a certain limitation on that particular wire rod. So you have to like do that, make more softer. So in order to go it to the 350 to the 150, you have to do the patenting process to make the wire more softer, and you can achieve the finished product characteristics. So that's one of the patenting process. Then our product will go through the patenting process, and after that we will be doing the more cold forming or the wire drawing process. And once over there, we will do the wire drawing process. We will send it to the oil tempering process, that particular product. So in oil tempering process, as I mentioned earlier, that we change only the internal, that process will change only the internal characteristics of the material. And once that's done, then we will be doing the further finished product testing, which involves that one, okay, this product has met our customer requirement or not. And once that has been done, then we will approve that particular product, and that will go. So like in the wire, I'm not sure like everyone has seen the wire manufacturing plant, but there will be like 20 strand lines will be running on the one machine, and all the 20 lines will be running at the different speed or temperature, or the going through that various speed. And those 20 lines can be millions of pounds or thousands of pounds will be producing in a day or so. So yeah, this is kind of like spring, I would say the wire manufacturing industry looks like. Again, if you are in the different industry segment, like medical industry or some other, the processes might be different. But that's how like currently we are manufacturing in the wire industry.
That's awesome. Thank you for walking through that entire process. I was curious about the purpose of enhancing or changing the internal characteristics of the spring wire via the heat treatment, the oil tempering. So my understanding is that these spring wires need to be able to withstand higher, stresses and tensions. Is that the
Yeah.
purpose of, changing the microstructure via this oil tempering? Can you just walk us through that process and the purpose of it in more detail?
Yeah, sure. So in simple, so once we have the cooled form or the wire drawn wire, that wire can be banded. If you try to bend, it will bend and it will retain its shape as it is. So if you have seen the spring, you press it, you release it, it will come back to its original state. So that's what the oil tempering process where comes in the place, and that plays a very crucial role. Like as a metallurgist, we call it the austenizing temperature. So we will heat up the product to the austenizing temperature, and once we will quench it to the particular temperature, we will form in the martensite structure. And then after that, we will doing the more tempering process on that particular product. So we'll form the tempered martensite, which is the very key microstructure in that our spring products, where so once you like I would say oil tempered wire products, we try to bend it and release it, it will come back. But if you bend more than so limit, it will retain its shape, and then it will not come back to its particular shape. So that changes the whole process, will change the internal microstructure, and which will change that mechanical properties of that particular microstructure. And this will help our customer that to make the particular spring or the application they are planning to use it for that one. So that's how, like in the oil tempered wire product, that's really, I would say, the heart of that particular process, which changes the whole characteristics before the oil temper and after the oil temper process.
Could you like just give a brief estimation? Like how much stronger does a wire get after being oil tempered?
So I can give you in the estimation based on the tensile
Yeah. Mhm.
properties, where you stress the wire and you will see where it's breaking. So like it could be vary on the range. Again, I cannot define very generally on that one,
Yeah, yeah.
but it
Mhm.
depends what is your product. Chemical composition is also plays the part on. It could be very range from the 300 to the 350 KSI on that particular range. But again, if you are different products, your range will be different on that one. So before the oil tempering process, you might be around, again, it goes to the chemical composition. So 100 and more than 150 ksi or something, 200 ksi more, and then you are changing the whole tensile range on that one. This is just the one of the characteristics on that one. Then you will be looking on the surface of that particular product on the microscope. It's also the one type of the microstructure detail, but you will look onto the particular surface. So that surface also plays the very crucial role on the spring manufacturing. If your surface of that particular product it's not well, there is a high chances while it's manufactured as a spring, it can break or something will not go right over there.
So now let's dive into one of the key responsibilities of your role, which is failure analysis. So we haven't discussed this in a lot of detail in a little bit on our podcast, but can you just walk us through the importance of failure analysis and maybe some of the problem solving methods or analytical methods that you use when trying to identify the root cause of a failure?
So failure analysis is really important. All the fields, I would say that one, because that will give you the chance of, or I would say the opportunity for improvement, either in the process side or either in the product side. So this is so failure analysis is really important. And then you can use various tools depending on the what type the product failure is looks like. Like either you can be, let's first go into the tool side, how that needs to be done, and then how can use that lean manufacturing tool or the root cause analysis part on that manufacturing for that particular failure. So tooling side, you can use the optical microstructure, the scanning electron microscope. Again, what detail you are looking into that particular failure, right? Like most of the failure analysis I've been doing on the microstructure level or the crack initiation, or I will be working with the third party to making sure that one, how it looks like under the like very detailed level, not further down from the microstructure level using the scanning electron microscope. So those are on the tool side. You can use the various other tools depending what type of failure it looks like. Like if your particular, it can be involved the tensile testing, or as well if you are doing on the failure on that particular end. So these are on the tooling side. And but if you look on the like various analysis side, you will be using the failure mode effect analysis, where you will be put the particular product, put the various process part into that. If this process is not right, can this product can cause that particular failure or not? If this particular process parameter is not at this set point, can this cause that particular failure? If those are the things are falling into the place, then you will look into the further detail. Okay, where this product came from, or what was the chemical composition look like for that particular product, how the surface looks like for that particular product that it has occurred. And then based on that factor, we will be I will be doing more analysis and then preparing the report that's involved. That's really important in the failure analysis. Whatever the process parameter or the failure parameters are involved, you will be combining those multiple factors and then preparing based on the analysis. I will be preparing the report and then putting that everything into the place and then come to a conclusion or what will be the next step in order to improve that particular products or the process side.
Very interesting. So I guess maybe so that all sounds very important to understand the failure, but one thing that I think we could see an effect is like the profit. And so you personally made huge contributions in growing your company's revenue almost at a 2x per year rate, which is crazy. What would you say is the most challenging aspects of your work? And is failure analysis the main reason why you were able to grow the revenue at such a high rate?
So I would definitely will say it's teamwork, which is the most important in the organization. Where together we worked as a team, and then we increase that revenue 2 times in the year. So it's not only the my failure analysis. I would definitely say it's various factors were involved. Yes, the failure analysis of one of them, but it's also the team together. We worked in a team to make sure what we are trying to achieve. So the operation side is the always challenging rather than the failure analysis, I would say, because failure analysis, I have most of the expertise. I can see what could go wrong on that and how to make sure we improve. But the operation side is really tricky, and then bring everyone on the same page and making sure we are doing as per it needs to be done, and bringing everyone onto the same page. It's always challenging on the operation side. And then process side is most of the time is like once you set the processes, that's always like 90% it goes smooth, but 95 there are 10% chances that it could go wrong. And then we did like a lot of improvement over the period of time. if particular like if particular failure happens, we will find that particular root cause and making sure that we will implement the corrective actions, including all the team members, because our team members are the very plays the really important role to making sure what we are doing on the process side or the product side, they understands and why that's important is requirement. So that's one of the thing that's required. And then once everyone comes on the team, then everyone will bring up that idea. Like quite often time I have seen that when we are doing the interactions meeting, which a lot of team members will bring up this, hey, let's implement this will improve this particular side of that product of the process, and then we will be further improve on that side. And over the period of time, we implemented those things, and that helped us to grow that. Like we produce the wire very consistently, very qualitatively, and then quantitatively as well. And that helped us grow the revenue way quicker than we have thought on that one.
Awesome. So speaking of those ideas, I want to touch on innovations that you're looking forward to in the field that you're working in, spring wires or even metallurgy in general. Are there any exciting upcoming innovations that you're in particular looking forward to in the near future, whether it's in like the next 5 years, next 10 years?
Oh, that's a tricky question because spring wire manufacturing is like 200 year or two more than that. I mean, like our headquarter has like in the museum, it's like they use the bull card to draw the wire. And
Oh
since
my
then
gosh.
now, yeah, so now we are drawing at really high speed, drawing the wire high speed at it's crazy high, like 1,000 feet a minute, or you can go like 2,000 feet a minute, that machine. So in terms of the innovation that we are seeing on the machine side, that trying to draw the wire faster, so that will increase the productivity side. And the more innovation comes from our end customer, we will not know even though what products they are working on, but as a spring wire manufacturer, we will have the certain quality characteristics, and that will be pretty like niche, I would say, very stringent requirement. And it's really hard to achieve, or it can various parameter could grow go wrong on that particular requirement. And those are the directly in related with that innovation that will be particular our end customer will be working on that one. It could be like cleaner surface, or it could be like they are looking for that particular quality requirement, can you fulfill that one? Because since they are really high end project, they will not tell us like what product innovation we are working on. But yeah, we always see how consistently and how qualitatively we produce the wire. So those are the innovation side. I would definitely would love to say that these things will be ongoing on that one.
Great. Well, that sounds great. I can't believe it's so old, to be honest. That's sounds like it's come a very long way. But maybe just to wrap up today's conversation, I just want to end on some advice about video analysis in MS. I think that MSc and metallurgy students are uniquely situated out of any of the engineering disciplines to be successful in failure analysis. And failure analysis is used in all fields, not just metallurgy, but I think all of us use failure analysis. So, what do you think that we can do as MSc students to further set themselves apart from in success when we talk about failure analysis?
So I think the first important thing is the academic background, that you take the courses that related with the failure analysis or your point of interest on that particular failure analysis. The important stuff is that how that particular material works, like material character, how that mechanical behavior works in the failure analysis technique. That academic foundation is the really key factor of on that one. Alongside, while you are doing the academic, it's really important you spend more time on laboratory and research, doing the research on the materials or particular failure, and then go back onto the, if you're doing the failure, then go back, work your way back, how this failure can happen, what process it came through, what was the material and those stuff. And the really important, the third stuff will be hands-on training, that do the internship in the industry you want to work. There are, it's a various industry in the States and across the globe. It could be the semiconductor or the metallurgical, like the heat treatment, or there is one more field, the melting department. It's also involved fields like that one. So do the hands-on training while you are pursuing the MSc, and then based on the training, your hands-on experience in the lab, develop your skills, how that will be correlated with all this stuff, and these analytical skills will really help you to develop your understanding on the failure analysis side. And there are various like lean manufacturing tools that's also plays the role on your failure analysis. Like you can use that particular tools like 5 whys, like why this failure happened. You ask the why till you find the end answer. This is one of the example. So you learn those manufacturing tools, and yeah, I'm sure this will definitely will get you, like in the failure analysis, feel easily to your developing your understanding in the analysis and the process side.
Yeah, appreciate that. There's not much I can really add to that because I think you had very comprehensive advice. I think there's a lot of companies nowadays that are implementing some of those like lean manufacturing methods, right?
Yeah.
Lean problem solving. Just one of them, just from personal experience, is GE. But I just encourage our audience to kind of look out for that. I think it is, a powerful problem solving method, good to learn, or just even doing your research offhand. You don't necessarily need to do the internship before learning about what Lean and Six Sigma are and what those methodologies involve. But overall, Nix, thank you so much for joining us today. It was a pleasure having you and pleasure learning about your field, learning about failure analysis and metallurgy in general. So again, very grateful for you joining us today.
No, thank you, Puneet and David. I really appreciate your time for going through this process, and I really appreciate that. And thank you for your time.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.